Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, here we are on Thursday, and as usual, I can see the weekend from here. I'm excited about it, so are you. Woohoo! So now, I've got to tell you first. So, what do you got a sweatshirt on with a hood? It's kind of cold down here in the bunker in Mesa. So anyway, that's why the sweatshirt. But is that a wonderful thing to have to say? You betcha, after all. The heat we had from who knows how long, May, June, July, August, September, into a lot of October, 5+ months of extreme heat. It's kind of nice and fun to have to wear a sweatshirt. You're probably thinking the same thing. I'll bet you are. Well, what's your job today, Mr. C? My job today, 7th graders, is to get you ready for your test. Now, you're going to do really well on your test unless you fight me, unless you go, I don't want to really listen to Mr. Chambers. Okay, that'll help you not do well tomorrow. Or, I don't want to write anything down that he says. Okay, that'll get you there. That'll get you a lower test score. Yep. So I'm kind of telling you how to get a lower test score. Okay, you're going to have to fight me, because I am going to, you heard the expression, you can't make a horse drink, but you can sure lead him to water. Well, I'm trying to lead you to the water, figure of speech, right? So you've got your lesson summaries out. So I'm just going to walk you through them. I'm going to guarantee what I'm going to ask you. I'm not going to tell you how I'm going to ask them, but I'm going to guarantee I'm going to ask this information. So I do this every week. Why? Because I want you to be successful. Not only that, and successful is not just a good test score. It's also, I want you to kind of learn the basic things as we go through this. So you have out a white sheet. I'm going to ask you a few white sheet questions. So you've got a white sheet out. You've got your journal at the ready, opened up to where you've been putting planet data down. So you've got that out. Okay. How long's the test going to be? My guess is on this one, probably a 40-pointer. Might be one of the longest you've had. Why? There is so much data. There is so much information. So anyway, my job is to give you the topics that are on the test. Your job is what? To triple R, big time. That's your job. So you do your part, okay? So it's a little bit like, God is sovereign and he does stuff. But what does he expect of us? Pray. He expects us to pray. That's a nice analogy, okay? All right, here we go. All right, so if you've got, I want to make sure I covered everything. I'm going to take you to LS9. LS9. So hopefully you've got LS9, then 10, 11, and 12. Nothing on LS14, but other than that, there'll be some things. Are you ready? Okay. So on your white sheet, this is what I'm going to ask you from LS9. So on your white sheet, give me an answer. I'll give you the definition, and you put down the term. What is this called? Where astronauts in space feel weightless. They don't feel gravity at all. What do you call it? There's a term for it. Number one, I will ask you. Show it to you on the lesson summary? Sure. There. Did you get it? All right. Number two, what do you call it when all the atoms or matter has been removed? No matter, no atoms. There's a term for it. What's it called? It's number two. And this is what space is like. If I said to you tomorrow, hey, give me the 2 characteristics of space that astronauts experience, like on the International Space Station. Number 1, a sense of weightlessness, no pull of gravity. What do you call it? It's called microgravity. Microgravity. Thumb up if you got it right. Did you get it right? Thumb up. Number 2, what do you call it when all the matter's been removed? No atoms. Space. That's space. What do you call it? A vacuum. A vacuum. Where all the matter removed, sucked out. Okay. So anyway, those two things, what are conditions like in space? That's the only thing from LS9. Okay. So have you got those circled? See them? Top box. Nice camera, huh? Anyway, I love this astronomy stuff. Do you get the idea that I like it? I hope I'm enthusiastic enough. I love this astronomy stuff. All right, LS10, LS10. So we already went over this yesterday, really quick, the geocentric, heliocentric idea. Geocentric, geo-Earth. Long time, for 1,500 years or so, scientists thought that the Earth was the center of the solar system. Not so, because Johannes Kepler, Tycho Brahe, Copernicus before them, and then finally the prime mover in switching over to going, nope, the sun is the center. Geocentric, heliocentric. The sun is the center. All the planets and all the other objects in the solar system go around the sun. Yep. Heliocentric. Okay? So anyway, I'll ask you Galileo. He was the prime guy. I'm not going to ask you for Copernicus. He put his 2 cents in there, more than that. And then Johannes Kepler, by the way, a really smart Christian who believed there was a God who designed everything. Tycho Brahe, before Kepler, and then finally Galileo. So, and there you have that. So we're still on LS10. So, and what is the solar system? Notice how I've circled solar system at the top and what it includes. Sun, planets, moons, asteroids, comets, the different components of the solar system. Sun system, solar, sol, sun system. So you've got it down there. Okay? So, anyway. So, I'm going to ask you that. So, LS10. Then, of course, geocentric, heliocentric. You've circled that. Hey, on your white sheet, what do you call this? The orbits of the planets are not circular. They are flattened circles. So number 3 on your white sheet, what are they? This is from LS10. So what are they exactly? They are called ellipses. Ellipses. Do it with your hands. Do it with me. Put your hand up. Make a circle. Both hands up. Make a circle. Do it with me. Mr. Gilbert's encouraging you. So a flattened circle, an oval is an ellipse. Do it again. 1, 2, 3. Ellipse, a flattened circle. That's the kind of orbit they have. What's the adjective for that, by the way? Say it out loud. What's the adjective? Ellipse is the noun. Elliptical. Elliptical. So, and I put down here on the solar system side, notice what I put at the bottom. I'm going to ask you that too. Oops, get it lined up right, Mr. C. There you go. My very educated mother just served us 9 pizzas. So, all of that, you're going to have to write it. Say it with me. My Mercury, very Venus, educated, Earth, mother, Mars, just Jupiter, served, say it, Saturn, us, Uranus, 9, Neptune, pizzas, Pluto. Now, you know that astronomers demoted or downgraded Pluto to dwarf status, 10 years ago or something like that. So I'm going to give you an argument why I think it should be a full planet. I'm going to tell you why in a little bit. Okay? So, anyway, there you have it, LS10. All right, LS11, how are we doing? How are we doing time-wise? Okay, so I've got enough time to do LS11. Okay, so LS11. And this is about the solar system as well. And I've got astronomy at the top. So astronomy, see that? Scientific study of space and space objects. Astronomy. And then I've circled planet, dwarf planet, and over here on this side, circle this. Do you see this? The sun has, can you see that there? 99.85% of the mass in the entire solar system. No wonder if you've got way more mass, then you've got way more gravity, aka gravity. So no wonder the sun is able to hold all of the solar system objects in an orbit. No wonder, because of its great mass, therefore it has a great pull. So, and then on this, and then I'm going to make my comment about dwarf planet Pluto. Okay, so right there it has an AU, an astronomical unit. It's a measurement. Notice I've got measurement there abbreviated. Astronomical unit. It is this distance. It's the distance from the Earth to the Sun, that distance, 93 million miles. I'm not going to ask you the exact number. It's an average of the distance that the Earth is from the Sun. Because the Earth has an elliptical orbit, it's sometimes a little closer than it is when it is at the, at the far end of its orbit. So when it's at this point and this point, it's a little closer, a little bit, not a lot. So anyway, astronomical unit, I'm going to ask you. Okay, I'm going to take a little break, turn it over to Mr. Gilbert. He can answer any questions that you have, clarify anything so far. So hands up for him, and I'll be right back. And I'm back. I just wanted to make the comment about Pluto. Listen to this. It says this. So it says a dwarf planet is an object that orbits the sun. Okay, Pluto. So Pluto qualifies as a planet. It orbits the sun. And then it says it has enough gravity to be spherical. Now that's an evolutionary idea. God designed Pluto that way. It's not like it, gradually cooled from a liquid, and formed that shape. God gave it that shape. So cancel that idea. So I don't like that. And then it says it has enough. But it has enough gravity to be spherical, but not enough gravity to have cleared its orbit. That means to pull other nearby objects in. That's evolution as well. Okay, God designed it to be what it is and have the moons that it has. Now it's got a bunch of moons. So anyway, so that's why I think Pluto should be a full-fledged planet. I'm sticking with that. Pizzas, Pluto. Okay, LS12. LS12. Remember my job to get you ready for the test? You're welcome. Okay, I'm on LS12. What do the inner planets have in common? There they are. Small, rocky, slow rotators, fast revolvers. Okay, I've got down there solid, that's the rocky part, few or no moons. So one more time. Inner planets, all the inners, Mercury, Venus, Earth, and Mars, small, rocky, slow rotators, fast revolvers, few or no moons. Okay? And then the characteristics of those inner planets. So I'm going to ask you for these three, and I'm going to have just enough time to do this. These three, okay? I can't do Mars, I don't have enough time. But I am going to do Mercury and Venus and Earth. So you're reviewing. I think you've got this in your journal. I don't care where you put this data. Now notice I've got the Mercury data right by my fingers. Mercury data. Here it is. So find in your journal. You got your journal? Got your journal open to your planet data? Are you there? Give you a little time to get there. Quick, quick, quick. Mercury is the smallest planet. Actually, it's not. It's Pluto, but, according to astronomers, for those evolutionary reasons. So if I said smallest planet and you put Pluto, would I give you the point? You bet. Okay. Or Mercury, a little bit bigger. Okay. And what are the key characteristics or properties of Mercury? First of all, it's got the largest temperature swing in the solar system. Wow. 850 Fahrenheit plus, 850 degrees Fahrenheit on the plus side. I mean, that's hot enough to melt lead metal, to turn it into a puddle, a liquid. Woo! We couldn't survive for seconds. We couldn't handle it. And then on the dark side of Mercury, when it's turned away from the sun, as it rotates slowly, by the way, very slow rotation, and no atmosphere, 2 reasons it has such a big temperature swing. So you're going to, if I ask you that, hey, what are the 2 reasons that Mercury has a huge temperature swing? Plus 850, minus 250, 1100 degree temperature swing. What are the reasons? No atmosphere to hold the heat in, and slow rotator. That means it faces the sun for a long time. It's a 59-day rotation, so roughly half of that, 30 days, 29, 30 days it faces the sun. And it cooks because it's so closest to the sun. So that's why it gets so hot. And it's got a fast revolution, 88 days. It's got to go around the sun really fast, or what would the sun do? Pull it in. So close to the sun. On the video you saw of Mercury, you could see that one little section or clip of the video where Mercury was going across the face of the sun, that little dot going across the face of the sun. So I think it's like 1,200 miles an hour or something like that. It's fast. I'm not going to ask you that, but it just pops in my head. What would you weigh on Mercury? Well, it's got way less mass than the Earth has. So if you were 100 pounds on the Earth, you'd weigh 38 pounds on Mercury. 38% of your Earth weight. Okay? And no atmosphere. It's heavily cratered because it has no atmosphere. So the meteorites just crash into it. Like the moon, yeah? And it looks like the moon. You saw the pictures of it. And you are seeing the pictures. You've been seeing the pictures of Mercury. So, and what it looks like. Looks like the moon. If I ask you on the test, hey, what other object in the solar system does Mercury look like? You're going to say, moon. Earth's moon, of course. Okay? So anyway, those are the keys. So, well, there's, that's it. Okay. And then Venus is next. Here's the characteristic of Venus. Boy, do I have to hurry. Okay? Venus, you saw the video on Venus. Hope you liked it. I like those little 3-minute National Geographic videos. Venus is basically the same size, diameter-wise, as the Earth. Not quite, but almost. Same diameter as the Earth. It's the hottest planet in the solar system. Is it hotter than Mercury? Yes. And we'll get into it why in just a minute. 900 degrees Fahrenheit. Woo-wee! I mean, it's cooking. So 900 degrees Fahrenheit. It's a very slow rotator, too. But I'm not going to ask you that. But there is something key about its rotation that I'm going to write down. I've got to write down right now and remind myself. And I'm going to tell you about it in just a minute. Okay. So Venus is it's the bad, nasty planet. I think it's the bad, nasty planet. Why? Because there are just horrible things about it. Now, in your lesson summary, it talked about the fact that Let's see if I can find it. There's only one planet that in the solar system where you could live easily. I put down at all. What do you mean easily? Who wrote that? So there's only one planet in the solar system that you could live on, period. All the others are just totally horrific properties, characteristics, where we die quickly, in a few minutes, a few seconds. So what else about Venus? It's got the extreme heat, 900 degrees. Now, one time it was thought to be the Earth's twin, exactly like the Earth, before we really knew what it was like, before we sent probes up there to it. And we go, holy cow, were we wrong? Wow. So it's got the 900 degree Fahrenheit. That's bad news. It's got a very thick CO2 atmosphere. That's the gas you breathe out. Now, if that's all that we had to breathe, carbon dioxide, we'd die in 5 minutes. Just, we couldn't get oxygen to our brain cells would die. 5 minutes. So CO2 atmosphere, really thick. So because of that, it blocks meteorites coming in. Asteroids too. Okay? It's got a really strong what's called greenhouse effect. That carbon dioxide gas, what it does is it traps the sun's rays and turns it into heat energy. That's the major reason it's so hot. Slow rotator, yes, but big greenhouse effect. I wrote it down. You can see it. And it's in the data. Can you see green? There it is. Move it over. Greenhouse effect. You see the 200 mile an hour winds? It's got like super, I think it's a class 5 hurricane that's like 150, 160 miles an hour. It's got 200 plus mile an hour winds. So can you imagine that? It would just pick you up. You wouldn't have to worry about it because you've already died from the other bad things. But if you survived all of those, it would pick you up and just carry you until you've smashed into something. And then it would be Newton's first law of motion. An object in motion will continue to move until it's acted upon by a force, something it runs into that would push back on it. Okay, so 200 mile an hour winds. It's got sulfuric acid falling from the clouds. That's not good. No, it's not. Sulfuric acid, so it would dissolve our flesh and our bones. Good. So I told you it's a bad, nasty place. Sulfuric acid. And then if that weren't bad enough, so listen to this. And then I've actually got a seventh one. This is Venus. Okay? It's got such strong pressure, like if you were 1,500 feet below sea level in the ocean. You would be crushed like an aluminum can. You'd just be crushed. All your bones would just... Ew. That's not fun to think about. You're right. So anyway, all these bad, nasty characteristics of Venus. 900 degree Fahrenheit temperature, high greenhouse effect because of the thick carbon dioxide atmosphere, CO2, 200 mile an hour winds, sulfuric acid rain all the time, really strong air pressure, and that's got volcanoes too. I think they're active. I think it's got active volcanoes. So, wow, Venus. Okay, so not a good spot to visit. Okay, I have just enough time to tell you about the last thing I'm going to ask. You should have this in your journal under, I think, Divine Designs. You've got about a dozen just rights for the Earth. This is the only spot in the solar system that was designed so life, and because God created it to match the Earth. It's not an accident. It's not like it gradually evolved to match the... That's just so silly, so ludicrous. God designed all organisms to be able to live on Earth because the properties of the Earth, the characteristics of the Earth, match the way He designed all life. Makes sense, huh? So what are Earth's just rights? I'm going to ask you for about a half dozen. You've got these in your Divine Designs. I'm going to go over them quickly. Distance from the sun, just right. Okay? mass of the Earth, amount of water, gravity of the Earth matches our bones. If the gravity was way greater, our bones would break. They couldn't hold us up. God designed the strength of our bones to match the gravity of the Earth, the tilt of the Earth for seasons, its rotation speed, its revolution speed, just right. Its magnetic field, which blocks cosmic rays from the sun. The magnetic field at the north and south poles. Okay, just right. So, the amount of land versus water, the ratio of land to water, just right. The kind of soil and the nutrients in the soil for plant growth. Just the right amount of plants to produce just the right gases in the atmosphere. It's got the right atmosphere with just the right ratio of gases. About 20% oxygen and about 80% nitrogen. Just the right atmosphere. It's got just the right moon to help balance it. Moon's got the right mass, gravity, right distance, the moon. Same thing about the sun. Just the right star. Sun's a star. Okay, the sun's got the right mass. The sun is made of the right elements that cause the right amount of fusion to produce the right amount of heat and light for us. Just right. Okay, so all of that, there's way over 15 just rights for the Earth. You've already got all those down, so I know you've got those. So anyway, that's tomorrow's test. Now, you're going to have a little break now. Mr. Gilbert will answer any questions. You can, he can help you if you miss something from the lesson summaries and what I just shared. So you can help each other too with his permission when he gets through. So, and if there's a couple of minutes left, a few minutes left, who knows? He might let you either study on your own or study with someone as long as you social distance and keep your mask on. It'll be up to him. Mr. Gilbert knows best. So I'll turn you over to him. He'll answer any questions during a second break. And at the end of every period, he's available to help you catch up, understand things, clarify things. It's one of the reasons he's there, for a whole lot more reasons. So do you ever thank him for doing what he's doing? He's working really hard on your behalf. So do you ever thank him? Do you appreciate him? Should you? Big time. Yeah. So thanks, Mr. Gilbert, for all your help every day. So take it away.